Right
No,
there.
no, no. It actually has a name.
Oh, shut up. The bulb mold.
No, it has a name. It's fire.
All right, guys. So if you notice, the thing said homework is on the textbook. Can you close this? Stop that, get out of notebook. And those of you new to this classroom, over there is where I write what we're doing today and what the homework is and what assessments are coming up. Sorry. Probably something on Friday, but Mr. Careless and I haven't quite finalized it. So, Fernando, you guys weren't actually seated together, so if you want to stay there. Thank you. So, guys, up here, top module, there's an online textbook. Your homework tonight is out of the textbook. It's on the flip chart and stuff, and I want to show you. So on here, you can fairly quickly search for the page. You can't see it because it's at the bottom, but there's a page number down there that you can say, go to page 470 or whatever fairly quickly. But this is, oh, I zoomed in too much. You can find the homework there. Yeah, so page 451 electronically is actually page 476 because it counts the preface as a page and the index and table of contents and stuff. But you should be able to copy them down in class or take a snapshot of it. Tomorrow, the trig inverse exit card for some of you did not go well at all. And it's because you still don't know and understand the unit circle. So there'll be some fixes for that. And there is projected to be a quiz on Friday. So, at the warm up. Complementary angles, anybody remember? What are they? Tycho, what do you?
That'd be angles for A.
Angles for A and B. Okay, what does complementary mean?
They complement each other?
I don't know
They do. Do they add up to be 180? Then add up to 90? Which one is it?
90.
90. So these things on the walls, I have students do visual explanations of things, and one of them that isn't up there, but she drew two angles and there were like people's faces in there and they were complementing each other because the two of them, if they fit perfectly, they are just right. I don't know.
37.
Yeah, okay, but some of you, all right, can you look up, this is very visual. If you can't remember which one is which, there's a C for complementary and S for supplementary. Ready? Fernando, you gotta look up, you gotta watch. Ready? It's exciting, thrilling. You're not ready. See? That's 90. The C comes for it. And look.
Girl.
Supplementary?
Oh,
See what
good.
she's substituting for 6th grade. Is that?
I'm wondering if we complementary angles out of when it's kind of right, like double time out of 180. So it's usually right.
Yeah, okay. All right.
That's the point.
So there's lots of reasons we have different names for these things. But A plus B, you guys are saying complementary angles, two angles that add to 90. So you guys were saying, whoa, that's A plus B in this case. So if A is 20, what is B? 70. Serene, if A is 50, what is B? A is 50, what is B? Corey. Mia, if A is 1, what is B? Okay. Here's the hard one. What's the hard question?
37.
If
I'm ready. Tell me
Yeah.
the question. A equals X, B equals Y. No, you first have to find X to find B, or you have to find B to find A.
Oh, no,
Hey, Sarah?
90 minus 6.
What? Where do you get this?
X plus B.
90 minus X.
No, it's nice, but like, that's not really finding you. That's
You need to take
I feel like that's just like you
Right.
wrote it.
Okay, Will, then you're really gonna hate this whole next unit. But hey, alright. So when A was 53, B is 37. When B is 16, A is 74. So the measure of angle A plus B, you guys all said 90. Perfect. Perfect. Okay, so at the top of your notes or wherever you are on your page, put the label co-function identities. Yes. Okay, co-functions work on complementary angles, the co's match up. You have this title written down somewhere, yeah? Switch in there. You have it written down somewhere? Okay. Alright. So, co-functions, you ready?
Yep.
Yep.
I gotta take this note real quick.
Okay, so draw the triangle. Carefully label the angles and the sides. The sides are 8, 15, and 17. Do you get out some notes?
Impossible. So what's 15 squared?
225,
What's 17 squared?
289.
And now what's 289 minus 225? 64. Yeah. And I'm a few guys because I know that. Yep.
It's true, it works.
Mhm.
Can you take the thing out of your nose? But I gave you all the values. You were just like checking to make sure that I wasn't like lying to you.
Yeah, I just do that. I'll be getting stuck sometimes.
Yusuf, what is sine of A given the labels that are here?
15 over 17.
So the opposite of A over the hypotenuse, 15 over 17. Octavius, what is this one? Sine of B.
Eight over 17.
8 over 17. Alvin, what is cosine of A?
8 over 17.
Peter, what is cosine of B?
15 over 17.
Okay, do you guys notice anything?
Yes.
Well, what do you see?
The sine of A is the same as the cosine of B, and then like vice versa for sine.
They got a relationship.
They got a relationship, they got a thing going on.
So we compliment.
Well, they're not exactly, okay,
They're not there yet.
yeah, we're not quite there yet. But do you guys see why? Sine of A is opposite over hypotenuse. Cosine of B, what was opposite A is adjacent to B. They will always and forever have this relationship. I don't know the actual sizes but do I know what A plus B is?
Yes.
90. Okay, so you guys just said,
Wait, whoa. Oh, yeah.
so Will was the one to say it, but like lots of you noticed, sine of A equals cosine of B, and that will always be true if it's a right triangle. The opposite of this guy is gonna be this guy's adjacent. Do you at least believe me? Okay. All right. So I'm gonna solve for A, like I Sarah did in the warm-up. A is equal to 90 minus B. Am I allowed to just get rid of A in this thing and put this business in there?
It's possible. Okay, 40, 50.
Okay. This is the cofunction identity. Cosine of B, that's equal to sine of 90 minus B, or pi over 2 minus B. Okay, let's.
Whoa, you skipped way.
Yeah.
This.
Oh,
Okay, back it up. All right, let's back it up. Let's back up.
Hold on.
sine of 90 minus.
Oh, it's confusing.
The sine line. Okay.
A plus B is 90. And if we're in radians, A plus B is pi over 2. Yep?
Yeah.
Okay, so Sarah gets it. What's wrong with the rest of y'all?
There's not too much.
Okay,
Is any?
A is 90 minus B, do you agree? Just algebra, right?
Oh, okay.
So here,
Can we just write it all in radians though, so we're like, I don't know, can we just do like,
excellent idea. A is pi over 2 minus B. Okay, Johan? Get off the phone. All right, so can't we do it all in radians? Excellent idea, Will, love it. So instead of sine of A,
We just switch.
we're gonna substitute this crap in, yeah? I didn't have $1, but I had 100 pennies. Does it still get the job done and let you buy something for $1? Yes. Three, good? Okay. So, Yusuf, you got a question? So to show you on the next page, like these pretty and like cleaned up, it can go either direction. And we got rid of the letter A and the letter B. Sorry, now that we're into like more trig stuff, they like to use theta, and when they have two of them, they like to use alpha and beta. Alpha looks like a fish and beta's got a little bit of a longer stick. It's okay, it's just Greek. Didn't you know learning math was good? I'm sorry, Adam, it involves Greek letters. You don't actually have to speak Greek, you have this painful look on your face. Do you have any new fun letters in your math?
There's like phi, a phi, and then there's also like one that looks like there are like 3 different versions of the letter P, but they're like technically different.
There's lambdas and gammas.
Yeah. Oh. It's awful. You just keep getting different letters. Like, I don't want this.
And they do those. Yeah.
But
Um,
gonna be.
Yeah.
and
it's not even a language.
don't worry, we don't get to those. We just okay. So if you guys are freaked out about these,
So are those supposed to represent
okay. These are just letters, Greek letters, and they stand for angles. We don't get to these. Those have applications in linear algebra and physics, and it's not this class. So, are you guys okay with these 3?
Wait, what's the middle one?
Do we have to know
You just, they're just, okay. Serene is like A, B, C,
Okay,
theta, alpha, beta.
Why did you need alphabet?
So
You'll get there, I'll show you. Okay. Good times. Now we got another little header to put in your notes. Pythagorean identities. We got the cofunctions, which by the way, those cofunctions work for all the things. Tangent and cotangent. Tangent of A is equal to cotangent of pi over 2 minus A. Secant and cosecant, they work for that too. Serene, write it down. Pythagorean identities. Peter, write it down. There it is. First thing he's putting in paper today. Ooh. Okay. Adam, do you remember what the Pythagorean theorem is in general?
A squared plus B squared equals C squared.
Does that work for all numbers, or like what is A, B, and C? Does it apply to a particular shape?
Yeah, the triangle. Well,
Any old triangle?
the right triangle.
Oh, right triangle.
Right triangle? Which one's the different one? Which one is the C?
C squared is the hypotenuse.
C is the hypotenuse. A and B are the two legs. They're called legs. They make the L of the 90-degree angle. Yeah? Okay. So we got this going on with trig. Not quite there yet. Peter, in the unit circle. Unit circle, what was the radius of the unit circle? 1. Alvin, in what is cosine of theta doing the letters here? Cosine of theta is what?
It's adjacent over
Adjacent over hypotenuse. So in the
X over 1.
x over 1, I'm not going to write the x. I'm not going to write the over 1. Okay, Monica, what is sine of y? Or sine of theta? Y over 1. Okay. So you guys agree with this?
Yes.
We already knew that. Okay. The number of times I need to repeat myself is like 8 in a day. But hey. Tomorrow. Now doing the Pythagorean theorem, not with x and y, but with cosine and sine. Gross. What is Pythagorean theorem?
Sine squared plus cosine squared
Equals 1.
Equals 1 squared, which is 1. You guys write that down. Write it down.
This only works for unit circle values though?
I mean, yeah.
Yes, for unit circle values, meaning for this hypotenuse being 1.
If it was like, if the hypotenuse was like 3, it's like just way safer.
It's just a straight or a stretch, so there's stuff we can do. All right. So I want to check. Is this true for all things? All right. So I want to try. Whoops. Sine of pi over 6 squared plus cosine of pi over 6 squared. All right. Cross from pi over 3. What's
3?
root 3?
1. 2.
So Gianna, looking at the triangle, what is sine of pi over 6? 1/2. Joey, what is cosine of pi over 6? All right. Jayla, what is 1/2 squared? 1/2 times 1/2? 1/4. Top times top, bottom times bottom. Yuan, what's root 3 over 2 squared?
3 over 4.
Town hall, what's 1/4 plus 3/4? 1. Okay, so that thing that we just calculated, that sine squared plus cosine squared, it equaled 1 for this case. All right, let's see, does it work for the pi report? Was that it worked? Maya, what is sine of pi report?
It would be
1 over root 2, okay? Fine with the leaders like that. What is, then what is cosine of pi report? Also 1 over root 2, okay?
1/2.
1 over root 2 squared is 1/2. This is also 1/2. 1/2 plus 1/2 is 1. Hey, it's like it's a thing that's always true because it is. So of all things, sine squared plus cosine squared equals 1. You need to know that. Okay,
Yo,
Let's be.
don't
You
you-
write real quick?
okay.
I'll take photo of you, bro.
These are posted
Oh, that's good.
and it's on a video.
Good.
So you can watch it.
I do that every
That would
day.
be fun.
I do that every day.
Oh.
The video here.
Okay. So you guys should have this written in your notes. Sine squared plus cosine squared equals 1. And we did the proof of that. Believe it or not, we did that as a proof. They're comments, Sarah, so if you're allergic to them, we'll get through it. Okay. So Peter, this instruction says divide everybody by cosine squared. What happens when I divide everybody by cosine squared? Peter? What do we do? Dividing each piece by cosine squared. What's sine squared over cosine? There's a, what trig function is that? Sarah said that's tangent. What's cosine squared over cosine squared? Cancels out to become 0? Is it 0 or is it 1? I got 5 cookies to share with 5 people. How much does each person get? Everybody gets 1. So it doesn't cancel out to become nothing. All those 5 people got a cookie. Not nothing, they got cookies.
Oh, that makes sense.
That's what I'm saying.
Cookies are important. Mia, 1 over cosine. Secant. So 1 over cosine squared is secant squared. Can you guys write this identity down? By Pythagorean theorem, we did sine squared plus cosine squared equals 1. And then if I divided everybody by cosine squared, I get this identity. All right, so now the next one. There's 3 different flavors of this identity. Dividing everybody by sine squared. Nick is telling the answer already. Sine squared over sine squared, you said it is 1. And sine over cosine is tangent, so Monica, what is cosine over sine? Cosine over sine. It's 1 over tangent, which has another name. Serene, can you close the computer, please? Cotangent, yeah. What is 1 over sine? Cosecant. So can you guys write this one down? Cosecant squared. And guys, it's important that you have those little exponents on there. 1 plus cotangent squared is cosecant squared. Tangent squared plus 1 equals secant squared. What do you think? Question? No? I can answer stuff, usually. I'm warmed up now.
Remember when you were showing us the Greek letters? So is that relevant for what we're doing? Like, or do they represent different things? Or are they just a
Okay.
variable?
You just look at the tool.
Genius.
Alright, guys, just to warn you, we will get to this eventually. It'll take a while. Honors is at this right now. Sine of A plus B.
There's sweats.
Wait, that's beta or not?
Is that A or
That's alpha and the B.
alpha, beta?
It's
Sine
So-
of beta, cosine of beta.
In honors, they're doing this right now. Yeah, ooh, don't worry. Not right now, not yet.
You're like the Wolverine.
Okay, you should not have to write these down, you should know them already. So I'm not gonna leave this up for long. But you guys do know that sine is 1 over cosecant, or cosecant is 1 over sine. You do know that secant is 1 over cosine, or that cosine is 1 over secant, like you know these, right? Tangent is sine over cosine, cotangent is cosine over sine, you should know these.
Let's say,
Fernando, you're giving it a look of like, we have met at one point in time, but like, no, I'm not sure how well we know each other anymore. It's like not contacting my phone.
That is actually what I was thinking.
let's say my sine is 1/2, right? So
Okay.
with my cosecant, it would be 1 over 1/2.
If sine is 1/2,
It would be a different angle though. Oh, never mind.
if sine is 1/2,
How do you do that?
okay. I'm gonna just turn it upside down.
Oh,
But what you said exactly, you said 1 divided by 1/2. Dividing is by multiplying by the upside down, it's the same deal. Okay? Okay, all right. Can you write that problem down? 1 minus cosine squared and a big old fraction bar with sine underneath. Here, where are the 3 straight identities? The Pythagorean identities. What's
1/4.
tangent squared?
1/4.
What's the one with the tangent squared?
How will you write out?
There were 2 other
You write out.
equations.
One divided by 2. That is sine squared, right? I was like,
Okay, so what we're getting to, this is it. This is the starter. I need to simplify. That means like if this was 25 over 50, that's gross. I don't want to do that.
Nope, you want to make that 1/2.
And if I don't see that, well, 25 is 5 times 5 and 50 is 5 times 10. So I'm going to reduce those and that's 5 over 2 times 5. Ah, okay, you're right. It's 1/2. Cool. All right. With these things, these trig identities, we're going to go one tiny piece at a time. So what looks like the more complicated lump? Ron, what do you see?
B.
Yeah, I think the 1 minus cosine squared angle can be like sine squared angle, right? Sine squared angle over a sine angle.
Okay, first of all, you're right. Like, let's look at this identity. The complicated part of this, so when we're simplifying, find the more lumpy looking thing. 1 minus cosine squared, that looks more lumpy than sine. So then we need to remember the stuff we know, the reciprocal identities and the things we just did. How do I get
See, you're gonna think of this.
how do I change this thing to look like that numerator? Not divided by sign.
Move the
Subtract.
one.
Okay,
Yeah,
Isabel
Oh,
says
yeah, yeah.
subtract cosine squared. Okay, no, just leave it there. That's 1 minus cosine squared. I'm gonna take the complicated thing out and put in sine squared. Are you guys okay with it?
No.
Tycho, no?
Don't get
Okay. So, here's my analogy.
No, it's just.
I got 4 quarters, unlike Sarah, I'm not allowed to take metal. Can I give you my 4 quarters and take a dollar? So, we're getting rid of 4 quarters and we're using a dollar. It's not just one, it's one sine. Sine squared over sine, one of the signs reduces. Okay,
Look at the cosine though.
okay,
times, yeah.
all right, question. Do you guys agree with this? We're just using the identity that we got. And Isabel said, subtract the same thing from both sides. Subtract cosine squared from both sides. So we did. So 1 minus cosine squared, that bigger lumpy thing. Hold on, Tycho, just a sec. Do we agree with that? That 1 minus cosine squared, that's the same thing as sine squared.
Yes.
So up here, so Tycho up here, the numerator was 1 minus cosine squared. Can I take this thing and replace it with just sine squared? So Sarah, can I take out this chunk, this side of the equal sign, and put the other side of the equal sign in? So then I have sine squared over sine. Tycho, do you still have your question?
I mean, I just wonder where we got sine squared from. But just the sine,
Because
they know.
1 minus cosine.
No? Sorry.
I see.
Okay. To solve these things, we need to, oh, okay, that was fun. Not yet.
Why so?
Sine squared plus cosine squared equals.
People obviously ask questions.
That's a thing you need to have in your notes, and you need to know that that's true. Okay. Given that, can I just do algebra and subtract cosine squared from both sides? Minus cosine squared, minus cosine squared. So this is 1 minus cosine squared.
Wow.
Okay?
Oh.
All right. I don't,
No, 1 minus
Wait.
cosine squared over sine.
so like, Mr. Hicks, I don't want to call you Mr. Hicks. I'm going to be like more cash. This is Mr. Hicks. I'm going to call you Van instead. Is that cool? All right, because we're buddies now. So ditching that and putting in something that is equal. Okay? So Tycho, you okay with that?
Yeah.
We're getting rid of that top thing. And it's not because of the bottom at all. It's because of this identity. Mr. Hicks is also known as Van.
Impossible.
Is this still part of the same question?
Yeah.
Yes, it is.
Never mind.
And sine squared is sine times sine. That's what squared means. So this yucky business simplifies down to just sine. Okay, you still have a question?
And it turns into sine.
Just sine.
It's just sine. It's just sine. There's no,
It's just sine.
it just boils down to that.
You look at my notes in front
Okay.
of. Sine squared is right.
Okay.
This, and then
So,
I forget.
this is like some work in between. So because of this is a little aside. Now that you have 1 minus cosine squared is equal to sine squared, you get rid of the top.
Yeah.
That's gonna become sine squared. The bottom is still the bottom.
Oh, yeah, yeah.
The overall thing that now reduces to the sine, just sine theta.
What is it? The 1 minus cosine.
It turns into sine.
Oh, I think.
I'm not gonna call you Mr. Hicks, it's just not,
It's 1 minus cosine.
it's like way too formal.
Is is 1 minus cosine squared the same as sine?
Sine squared. It's the same as sine squared.
Oh, that makes a lot more sense.
Yes. Okay.
One.
Well,
As I originally thought, it was should be 1 minus cotangent.
You get that.
The sine squared on the bottom was,
there is no sine squared on the bottom.
but if it was squared, could that work? I mean, I thought like cosine over sine.
Okay. Yeah, you're making it too complicated and like let's just do with the question as it's written and that doesn't work. Just okay, guys, all of the things matter. The top became changed. Instead of 1 minus cosine squared, I'm calling it sine squared. Why? Because I know this identity and that's true. I just did algebra and moved one thing to the other side. Guys, so I swapped stuff out. Now looking at what it became, that's like 10 over 5. This is like, I swapped out the top, and then I can reduce. 10 is 5 times 2, the bottom was 5 times 1, it became just 2. This was sine times sine divided by sine. Well, one of them canceled. Okay, let's try looking at the other one. Ooh, I know, scary business, write it down. Yeah, it's gonna be a okay, u is just another variable. It's the angle.
Is it like the same thing as like? Oh,
It's the same thing as like beta, same thing like x.
Oh,
Just call it.
Yeah, calculus, my students, they were like, I can solve if it was f of x, but they called it b of x, b for like bird population, and they're like, I couldn't do it. Really? Like,
I could do that.
it was just a b, and they're like, no, couldn't do it.
I'm proud of you.
Monica, do you have it written down? Peter, do you have it written down? Okay,
We should do it.
now I gotta remember those identities that we proved a second ago. Maya, what's the one with the sine squared in it? What's that identity? Fernando, what was another one of them?
Balance it out. Tan squared theta plus 1 equals secant squared theta.
I agree. Tycho, what was the last one?
Cosine squared.
Wasn't cosine.
Wait for, it was 1 plus cotangent.
Cotangent squared equals.
C.
One plus cos squared.
Okay, yes, Isabel.
Are all of those still true if you take away the square?
They are not at all true if you take away the squared.
The Pythagorean theorem, or a squared plus b squared equals c squared.
Okay, so, okay, guys, it's important that, yeah, the squared super duper
Everything
matters.
matters.
Everything matters.
Every little detail.
Okay,
All relative.
Okay, so.
but it is not true if they're not squared.
So let's see.
Hold on.
The same thing as
Guys, 3 squared plus 4 squared
plus cosine squared. Because the tan-
equals 5 squared, but does 3 plus 4 equal 5?
Oh wait, just equal.
Oh.
No, so the squareds matter. All right, Serene, what's your question?
I have a question.
Why did you put tan squared plus 1?
Okay, guys, stop. Hang on.
I got it.
I drew one out today, bro.
Okay, hold on. 3 of you are done, and 30 of you are like, I don't know what we're doing. These things are just what we proved on the other page. I'm just asking you to believe that they are still in your notes. If they're not in your notes, write them down. Okay, you on one step at a time. Just tell me one step. What's one thing you see?
Sine squared u plus cosine squared u equals 1.
Okay, stop there.
You don't get it, bro?
No, I did not.
Yuhan sent me his genius powers, and I understand now.
So all I did was rearrange. So he says, those two added together, Adam, what is sine squared plus cosine squared?
1.
1, excellent.
Oh, yeah.
So now up top we have 1 plus tangent squared u over secant u.
That one.
William, what'd you see?
You look something.
I see that it's tangent squared plus 1 equals secant squared, and secant squared over secant is secant.
Yeah, then it's
Oh.
I'm genius, Yuhan. I'm genius. You're no longer genius, I'm genius.
High five.
I'm not high-fiving you, bro.
You know, it's not like there's only
I know,
one.
genius.
William, it's not like there's only one. You're all allowed to be genius. And you're welcome to fight over it.
I'm the most genius.
Oh. You should have seen Jacob's face when he said that. She kind of like did the eye roll of like,
I think everyone is doing the eye roll.
Everyone
Whether it
just
was
said
intended or not, it was priceless.
Wait, so
Okay, so yes, Joseph. Nope, we're good.
you're
This is it. This is it simplified. That's as clean as it gets.
so seeking you turn into tangent squared plus 1.
Okay, guys, so the process was Yuan saw sine squared and cosine squared, got rid of those and made it become a 1. And then William said, what's left? 1 plus tangent squared, we know an identity that says that's secant squared. So we got rid of that numerator, put in secant squared. Secant squared divided by secant. One of the secants from the top cancels with the one on the bottom. Hang on, guys, take a picture if you don't want to look it up on the book. The problems are listed at the top, so there's more problems on here.
The answers?
The answers are under little purple boxes, so if you have x-ray vision, you can see them.
What do you like to talk about?